All right, so we're going to start talking about derivatives of inverse functions. And um, so earlier today in class, we talked about how to find a certain value in the inverse. But we're going to start talking about derivatives of trig functions, but we need to talk about inverses and what they are. So we're going to review inverses, which we already did in class, but let's review it again. So to find the inverse of a function, you switch x and y, and then you solve for y. Okay. So an example here would be x equals 5y plus 2, x minus 2 equals 5y, y equals x minus 2 over 5. All right, so that would be the inverse of 5x plus 2. So on this one, it'd be good if you pause the video and then try to do them and come back and see what my answers are. So x equals 2y minus 3, x plus 3 equals 2y, y equals x plus 3 over 2. So this function is not one-to-one without the restriction. With the restriction of x being greater than 0, because it's going to be a, here, let's think graphically. So that's that function, x squared is a parabola, and it fails the vertical line test, so therefore it cannot have an inverse. But if I restrict it to just all the positive x's, then that's okay. It passed the horizontal line test, and I can find the inverse. So x equals y squared, y equals square root of x. So that's the inverse. Last one, x equals tangent y, and then be tan inverse of x equals y. We can always call that the arctan of x. Same thing. So arctan is the same as tan inverse. All right, we're gonna do a triangle method, and just so we remember how to do the Pythagorean theorem, we're going to write an expression for side A of each of these triangles. So let's just also remember Pythagorean theorem says that a squared plus b squared equals c squared. Okay, so that's the idea here. So remember, when we do Pythagorean theorem, a and b can any of the two sides. C is always the hypotenuse. So here we have 1 squared plus x squared equals a squared. Again, we're finding the expression for a. So 1 plus x squared equals a squared, square root both sides. 1 plus x squared equals a. I know I square rooted both sides, and it'd be plus or minus, but I'm only looking for the principal square root here and the positive one, so this would be it. Okay, this one we would do a squared plus x squared equals 1 squared. Again, we're solving for a. And then square root. So a equals square root of minus x squared. So this is important to be able to do when we get to the next part here. So a squared plus 1 squared equals x squared. A squared equals x squared minus 1. And a equals the square root of x squared minus 1. All right. So let's remember trigonometry. All right. If a right triangle has legs of length a and b and a hypotenuse of length c, and angle A is the angle across from the side length of A, then I want to find the ratios of the following. So, if right triangle's legs left A and B, so this is A, and this is B, and the hypotenuse is C, and angle A is here, I want to find the ratios of the following figures. So here, sine A equals, so remember SOHCAHTOA, okay? So SOHCAHTOA says opposite over hypotenuse. So sine of A is B over A. Cosine of A would be, I messed that up. How about not B over A? How about B over C? So opposite over hypotenuse, sorry. Adjacent over hypotenuse. Tangent would be opposite over adjacent, so B over A. Secant. Now, secant, cosecant, and cotangent. Remember, those are just the reciprocals. So the reciprocal of secant. So secant goes with cosine, so not the reciprocal, secant. Secant is a reciprocal of cosine. So secant would be C over A, cosecant would be C over B, and cotangent would be A over B. All right. So here we go. Let's review the derivatives of our regular sine functions, okay? So the derivative of sine is cosine, and since it's derivative of u, we take the derivative of the outside, keep the inside, times the derivative of the inside. So that'd be u prime cosine of u. So derivative of cosine is negative sine, so it'd be negative u prime sine of u. Derivative of tangent is secant squared, so it'd be u prime secant squared of u. Cosecant u is negative cosecant cotangent, so negative u prime cosecant u cotangent u. Derivative of cotangent is negative cosecant squared, so negative u prime cosecant squared u. And the derivative of secant u is u prime secant u tangent u. Okay, that's going to be important for the next part that we do. Okay, so we're going to start talking about derivatives of inverse trig functions. And in this case, when we do the derivative, there are formulas, but instead of memorizing the formulas, there's a way to do it using a right triangle, okay? Because remember, trig is all about right triangles. So I'm going to show you how to derive each of the trig functions, okay? Or the formulas for a trig function so that you can find the derivative of any of those functions. Alright, so there's some steps that we're going to do in order to do this, and we do the same thing every time. That's why I'm going to do all 6 of them. It's going to take me a second, but it's going to be helpful, and it's definitely something you want to practice and you want to get good at because, like I said, memorizing the formulas on top of all the other formulas that we have sometimes is just hard. So here we go. We're going to find the derivative of inverse sine. So our first step is to undo the inverse, okay? So that would just be sine of y equals x. So all I did was undo the inverse or take it of both sides. Okay. So remember, sine is so sine is opposite over hypotenuse. So let's label our triangle, okay? So I'm going to label this y, okay? And the sine of y is x over 1. So opposite over hypotenuse, okay? And so what I want to do is now find the derivative of this equation. So the derivative of that is cosine of y dy dx equals 1. Now, we're going to start using something different for dy dx. We're going to use y prime. That's the same thing. It just makes life a little bit easier. So cosine of y times y prime equals 1. Let's solve for y prime. So y prime equals 1 over cosine of y. Now what I want to do is I want to use my triangle, okay, that I just built using sine to now write an expression for the third side because I don't know what the third side is. See, this third side is completely blank. So let's figure out what that third side is based on the triangle that I built. So let's just call my third side a for now, okay? So a squared plus x squared equals 1 squared. A squared plus x squared equals 1. A squared equals 1 minus x squared. So a equals the square root of 1 minus x squared. So what I just did is now I have this value for my third side based on the sine, the sine y of x. So I built the triangle based on sine y of x, and then I solved for the third side. Well, now I can take my y prime, okay, and I'm going to plug in cosine of y based on the triangle. So the cosine of this triangle would be adjacent over hypotenuse, okay? So y prime equals 1 over the square root of 1 minus x squared, okay? Because cosine, right? Cosine of y equals adjacent over hypotenuse. Cosine of y equals the square root of 1 minus x squared over 1. So I put that in the denominator. And this is the derivative of sine inverse of x. Okay? Okay, let's do the same exact thing for cosine. So first we're going to undo the inverse. So it's going to be cosine of y equals x. I'm going to build my triangle based on cosine. So cosine is adjacent over hypotenuse. Then I'm going to take the derivative. So I get y prime, or negative y prime, sine of y equals 1. And then I'm going to solve for y prime. So y prime equals 1 over negative sine of y. I'm going to find my third side here. So I'm going to find what this third side is. So I can just let that be a. So x squared plus a squared equals 1 squared. So a squared equals 1 minus x squared. A equals the square root of 1 minus x squared. So now I'm going to figure out what the sine of y is on this triangle, since now I know that this side is the square root of 1 minus x squared. So sine of y would equal my opposite over my hypotenuse. So I'm going to plug that in. So y prime equals 1 over negative square root of 1 minus x squared. All right. All right, let's build tangents. So first thing, undo my inverse. So it'd be tangent y equals x. Then I'm going to build my triangle. So remember, tangent equals opposite over adjacent. So this is y, make it a big Y. So tangent equals opposite over adjacent, okay? And now we're going to take the derivative. So remember, the derivative of tangent is y prime secant squared of y equals 1. Solve for y prime equals 1 over secant squared of y. So now we have to figure out the expression for secant. So let's first finish our triangle. So I'm going to call this a. So 1 squared plus x squared equals a squared. 1 plus x squared equals a squared. So the square root of 1 plus x squared equals a. So this side is 1 plus x squared. All right. So secant is the reciprocal of cosines. Remember, cosine of y equals adjacent over hypotenuse. So that means secant of y is going to be hypotenuse over adjacent. So secant of y equals my hypotenuse, 1 plus x squared, over my adjacent. Okay. And so I'm going to put this in the denominator. So that's just 1 plus x squared. So I've got 1 over 1 plus x squared, but squared because we're squaring secant. So y prime equals 1 over 1 plus x squared. So that is the derivative of tangent inverse of x. All right, so then cosecant inverse of x. So remember, cosecant of y is the reciprocal of sine. So hypotenuse over opposite. So, excuse me. So let's undo our inverse. So we're going to get cosecant of y equals x. So let's build our triangle. So y, and you remember cosecant is hypotenuse or opposite. So x over 1. Remember where I'm getting the 1 is from here. All right. So now let's take the derivative of cosecant of y. So the derivative of cosecant of y is negative cosecant cotangent. So negative y prime cosecant of y cotangent of y equals 1. Solve for y prime, so we get y prime equals negative 1 over cosecant of y cotangent of y. All right. Now we need to figure out what both cosecant of y is and cotangent of y is in order to build our equation. So first we got to find our third side here. So remember we call that a, our third side. So a squared plus 1 squared equals x squared. A squared equals x squared minus 1. A equals the square root of x squared minus 1. So we have two that we're plugging in. We have to find cosecant and we also have to find cotangent. So let's find the expression for cosecant of y. So cosecant of y is going to equal hypotenuse or opposite, which is just going to be x. And then cotangent of y, so cotangent is going to be adjacent over opposite. So that's going to be our a value, which is the square root of x squared minus 1 over 1. Okay, so we can just call that the square root of x squared minus 1. So we replace that in our y prime, so y prime equals negative 1 over x square root of x squared minus 1. So that is the derivative of cosecant inverse of x. Okay, now we can do secant of x and cotangent of x. I want you to do those on your own. I'm going to give you the answers. So the derivative of secant x is 1 over x square root of x squared minus 1. All right. And the derivative of cotangent x is negative 1 over 1 plus x squared. So I want you to try to derive those. We'll talk about them more in class, but that's what I'd like you to do.